Hey there, have you ever glanced at a screen full of code and just thought, wow, that looks complicated? I totally get it. But what if I told you it's a lot more like learning a new language than doing some crazy complex math? Today, we're going to take our very first look at Python, a language that's famous for being one of the best for beginners. Let's see if we can make it all click. So, everything really starts with one simple question. How in the world do you tell a computer what to do? I mean, you can't just talk to it, right? You can't say, hey, figure this out for me. We need a really specific shared language to give it our commands. And that kind of gets us to the heart of the problem. On one side, you have us, humans. Our languages are rich, they're full of inside jokes and sarcasm and context. On the other side, you have the computer. It only understands one thing, machine language. And that's just a super precise stream of ones and zeros. That is a massive gap to cross. So how do we bridge that gap? Well, we use a translator. And in our case, that translator is Python. It's what's known as a high-level language, which is just a fancy way of saying it lets us write instructions that are way, way closer to plain English. And you know, I love this idea that programming isn't just a dry technical skill. The legendary computer scientist Donald Knuth said it perfectly. He called it an art because you're using your skills and ingenuity to create objects of beauty. That's such a powerful way to think about what we're actually doing here. So, of all the programming languages out there, why are we talking about Python? Well, for one, its rules, its syntax, are famously clean and easy to read. It's also totally free and open source, which is huge. Plus, it has this massive library of pre-built tools for you to use. But the real game changer, especially for us right now, is that it's an interpreted language. That's the secret sauce for learning. Okay, so what does interpreted actually mean? It's really pretty simple. First, you write your instructions in Python. That's called your source code. Then, this program called the interpreter reads your code, but here's the key. It reads it one line at a time. It translates that one line and has the computer do it instantly. Then it moves to the next line. This line-by-line thing makes it so much easier to learn and to find mistakes as you go. You know, just like any language you might speak, Python has its own grammar rules. And once you learn just a few of the basic building blocks, you can start putting together actual instructions. So let's dive into those fundamentals right now. All right, the single most important idea to wrap your head around is the variable. Seriously, the best way to think about it is just as a labeled box. You give the box a name, you stick some information inside of it, and then later on your program can look in that box to see what's there. It's how a program remembers things. Okay, so we've got our labeled box, but we also need to tell Python what kind of information we're storing. Is it a number? Is it a word? These categories are called data types, and they're super important because they tell Python what you can and can't do with the info inside that box. First up is the int, which is just short for integer. This is your go-to for any whole number. 1, 50, 101, -20, no decimals. Simple as that. But what if you do need decimals? Well, for that, you use a float. Think of numbers like 3.14 or, 987.9. If it's got a decimal point, it's a float. And finally, for any kind of text, we use something called a string, which is short for string. All you have to do is wrap your text in quotation marks and boom, you've got a string, like keep smiling. I love this way of thinking about it. If variables are the nouns of our language, then operators are the verbs. They're the action words. They let us do stuff. And these ones right here are the most basic tools for doing math. Plus, minus, times, and divide. All right, we have variables, we have data types, and we have operators. We have all the pieces we need. So let's do it. Let's put them all together and write our very first program. So our goal is going to be really simple. Calculate the area of a rectangle. The first thing we do is create a variable, our little labeled box, and we'll call it length. Then we use that single equal sign, which in programming means put this value inside, to store the number 10 in it. Easy enough, right? Next up, we do the exact same thing for the breadth. We make another box, we name this one breadth, and we assign it the value of 20. And here it is. This is where the magic happens. We create a brand new variable named area. Then we tell Python, hey, go look in the length box, multiply that by whatever's in the breadth box, and then store the final answer in this new area box. Okay, the calculation is done, but right now the answer is just sitting in the computer's memory. To actually see it, to get it on the screen, we need one last command, print. We just tell it to print whatever value is currently inside our area variable. And there it is. When the interpreter runs through our 4 lines of code, the output it spits out onto the screen is 200. That's it. You've just walked through a complete, working computer program. How cool is that? Now, one last thing, and this is super important. As you start writing your own code, things will go wrong. You are going to make mistakes. Everybody does. So learning how to understand those errors, or bugs, is honestly one of the most important skills you can have. Generally, you're going to run into 2 kinds of errors. The first one is a syntax error. Just think of this like a typo or a grammar mistake in English. You broke a rule of the language, and Python will actually stop and tell you exactly where you messed up. The second one, a logical error, is a little sneakier. The code runs just fine, no crashes, but it gives you the wrong answer. That's because your logic was flawed, not your grammar. So there you have it. We've gone over the absolute fundamentals of how to talk to a computer, using variables, data types, and operators. We even built a tiny working program from scratch. So the big question I want to leave you with is this. Now that you have these first building blocks, what will you create?